Everyone, I'm sorry I did not realize that some of those questions on those games go more into detail on ions and ionic charge. So here are some quick notes to set you up so you know what you're doing and how to answer those questions. So before we start with just looking at our looking at our ions, we need to make sure we know what we've been playing with. What are the atoms in comparison to that? So an atom, remember, is the smallest unit of an element that still acts like that element. Start to get smaller, and you can't tell the difference between a proton from an oxygen atom versus the proton from a fluorine atom. They act the exact same way. They act like protons, not like oxygen or fluorine. This is also true of ions. They're still that smallest unit. But in atoms, they have no overall charge. In other words, they have a charge of 0. Don't know why I skipped that. And what this means is that the proton and electron numbers are both equal to the atomic number. Now this is what changes in our ion. So in our ions have either, man, I can't spell today, my apologies, either a positive or negative charge. And the proton number is still equal to the atomic number. That does not change. Okay. However, the electron number is either more or less than the proton number. It is the number that changes. So, when we're looking at your periodic table, you will notice that all of your nonmetals here on this side of the staircase have a negative charge. With your metals, all of your metals has a positive charge. So, metals have a positive charge, and nonmetals have a negative charge. And there is a reason for this. The reason for this is what is going on. So all of your nonmetals over here, you notice, have a negative charge. What that means is they have gained electrons, because electrons is the number we're changing, remember? The proton number stays the same. So if we gain electrons, if we have more negatives, because that's the charge in an electron, electrons have this negative charge. So if we have more electrons, we're going to have an overall charge that is minus. So fluorine here has a negative charge of 1. So that means it's not going to have 9 electrons, but it's going to have 10. So electron-wise, it's going to look like neon. Oxygen, 2. So that means 1, 2, again, going to look like neon. In fact, that's true of all of these. So everything in this first shell, nitrogen, oxygen, fluorine, gonna look like neon. Phosphorus, sulfur, chlorine, gonna look like argon. Arsenic, selenium, bromine, gonna look like krypton. They're always trying to look like the thing that has the nearest full shell. Same goes over here. When we're taking a look at our positive guys, when we're looking at our metals, beryllium loses 2 electrons, has that positive charge. So if it loses 2 electrons, it's not going to look like beryllium. It's not going to look electron-wise like lithium. It's going to look like, looping all the way around, like helium. If we take a look at sodium, say, sodium here is going to lose 1 electron. It's going to look like neon. So for most, doesn't go for the transition metals, but for most ions, what's going on is they're trying to figure out how they can have a full shell. That is the name of the game with ions. So most ions have a full electron shell. That is why metals have a positive charge and nonmetals have a negative charge. So let's actually put this to the test. Let's verify what I said by taking a closer look at oxygen. So first thing I'm going to do is copy out my information here onto my page. So oxygen, here in the middle, O has an atomic number of 8, atomic mass is 16, and atomic charge of 2 minus. So O, 8, 16, 2 minus. So this is your atomic number, your atomic mass, and this is your ionic charge. Excellent. So, when we are figuring our things out, our proton number always, always, always is the atomic number. That's true of atoms, that's true of ions. So, that means we're going to have 8. Quick and easy. Neutrons, we learned, you just take your atomic mass, in this case 16, subtract our atomic number. In this case, we also get 8 neutrons. For electrons, when we're working in ions, we start at 8. We start at that atomic number. And then we do something funky. We do the opposite of the ionic charge. So, if we take a peek at our ionic charge, we see we have 2 minus. So the opposite of 2 minus is to plus 2. Well, 8 plus 2 gives us 10. Why do we do the opposite of the ionic charge? Well, the reason why we do the opposite of the ionic charge is that electrons are negative. So, an ionic charge of 2 minus means we have gained 2 electrons more than our protons. Okay, good. So, let's draw this out. Let's test it. So, we start with our protons and our neutrons. We've got 8 and 8. Remember that first nucleus never gets touched. And then we're going to take a peek. So, electron-wise, we are going to look the same as what has the atomic number 10. So we've gained 2 electrons. So when we're looking at an atom, not our ion, but what we normally do is we look at oxygen and say, oh, well, it's going to have 2 shells because oxygen is 1, 2, 3, 4, 5, 6 over. It's going to have 6 electrons. But that is not the case. Now we need to look at not what has atomic number 8, but atomic number 10, because we have gained 2 electrons. So atomic number 10 is going to have 2 full shells. So that's what we draw it as. Our protons and neutrons stay the same. That's how we know we're still dealing with oxygen. But electron-wise, it is going to look like neon. And that's how we know our Bohr model is of an oxygen ion rather than a neon atom. Excellent. Okay, so going from there, I'm going to flip the page. Here's the deal. When you are playing some of your games, they are not going to have you building your Bohr models per se. They're going to give you some numbers, and you have to figure out what's going on. So let's look at some examples. If I give you a scenario where you have protons equal to 1, neutrons equal to 1, and electrons equal to 2, and I want to know the charge, right? That charge we often call the ionic charge, but I don't believe it does so in your game. Well, we know we have gained 1 electron. So 2 minus 1 means we're going to have a 1 charge. And electrons are negative. So it's going to be a 1 minus charge overall. So electron minus our proton number. What about if we go in the other direction? So what if we have protons, neutrons, and electrons? This time we have 12 protons, we have 12 neutrons, and we have 14 electrons. Well, what we're going to do is we take, sorry, not 14, we have 10. What am I doing? There we go. So this time, we can see we have fewer electrons than protons. So we can switch this around. We can this time take our protons minus our electrons. That tells us we're going to have a 2 charge overall, because the difference between those two is 2. But protons are positive, so we are going to have ionic charge of 2 plus. Okay. The one other thing I want to remind you of before I let you go is you must remember what is going on with our atomic mass, because there's quite a few questions about that. So you must remember, how do we find our atomic mass? Well, atomic mass, remember, is just your number of protons plus your number of neutrons. Electrons are far too light. They do not have any mass at all, not compared to the other two, so they do not factor in. You just add those two together, and you get your overall atomic mass. Another important thing, where it might be helpful for you to write this down, what I'm going to write down right now, is that when they're looking at an element, let's pick neon. No, let's pick helium as an example. If we take a peek at helium, they are still going to put the ionic charge here We agree on that between our format and theirs, but they switched the other two numbers. So for us, this number is where we would put the atomic mass. That is not where they put the atomic mass. They instead put the atomic number here. And here is where they place the atomic mass. That will be a big help for you. Okay. Have a good day, everyone. Thank you for listening.